Again, working through set problems, chapter 1, whole numbers. Okay, on the first problem it's asking us to simplify the equation. So we are going to multiply the numbers out and add them together, so we get 70,000 plus 2,000 plus 300 plus 50 plus 6, and we combine that, we get 7, 2, 3, 5, 6 for our value. The next question asks us to round to the nearest thousandth, so that means that we are looking here, this is our thousandths place, we look at the number to the next and realize we're rounding up, so we get 9, 4, 3, 1, 2, 3. On our simplify the equation, we're going to add the two values, 47 plus 58. And so on our calculator, if we hit reset it, clear all our values, we're going to add 47 and 58, and we get a total of 105. Our next problem, we're going to add the following numbers. So 791 plus 21,362 plus 356, 925 plus 5471 equals our grand total of 384,549. And that is problem number 4. Okay, we'll turn the page. Alright, on here we are going to subtract the two values. So we'll take 183, we're going to subtract 75, and we get a total of 108. Here we're going to take 23,745 and subtract 6,943, and we get 16802. 14 times 37, and we'll get 518. On this problem, we're going to take 7,903 and we're going to multiply it by 57, and our total is 450,471. Okay, that is problem number 8. Here we're going to take 98 and we're going to divide it by 7. So we can put 98 divided by 7 and we get 14. We could also use the fraction tools on here. 98 fraction 7, and we get the same value. Here we want to simplify the equation. So we can take the 21,768, divide it by 34, and in this case they want it as a mixed number or a fraction. So we will use our fraction tools here. 21768 fraction 34, and we get a whole unit of 640, and we get 4 over 17. Our next problem asks us to calculate the resistance in series. We're going to add these three numbers up. So we've got 20 ohms plus 24 plus 35. So we can do 20 plus 24 plus 35, and we get a grand total of 79 ohms. Here the total resistance of two resistors is 63, So we say 63 equals the 37 plus our unknown. If we subtract 37 from both sides, our unknown becomes 63 minus 37, and we get a total of 26 ohms. Problem number 13 tells us we have a coil of wire. It has 16 layers and we have 17 per layer, so we're going to multiply those two numbers, 16 times 17, and we get 272 total turns. Okay, number 14. If we have a length of cable, it's 192, and we are putting a staple at the start and the end. Notice that we have two staples and we divide that whole length to 192. If we divide it in two spots, there's 1, 2, 3 staples, and we divide 192 divided by 2 equal sections. So if we take the number of staples and we subtract 1 from it, that's going to tell us how many sections. And we're going to take the full length of the 192 and divide it out there. So 192 divided by 48, and we get 4. Number 15. The job takes 17,000 and some odd feet of Romex cable. We need to round to the nearest thousandth. So we're going to look here. That tells us to round up. So we get 1, 8, 1, 2, 3. That's the approximate number that we need. Now, if they're in 25-foot rolls, how many rolls do we need to order for this job? Well, we can take that rounded number, that 18,000, and divide it by 250. And we're going to say, well, about 72 if we approximate it. If we want to go off the actual number, 17842, and we're going to divide it by 250. 17842 divided by 250, and we get 71.368. So we have a partial roll here. We're going to round up to 72 rolls. Number 16 says when a new job is begun, there are 30 rolls in stock. Each roll contains 250 feet of cable. We get 8,750, and that's feet of cable. And then the first day he uses 1,347 feet of cable. So if we subtract 1,347, we come up with a total of 7,403 feet. Okay, during a 1-week pay period, an electrician works 37 hours and he gets a total pay of $555. We need to determine his hourly pay. So we're going to take the pay and divide it by the time. So our divisor is going to be the 37 hours. The dividend is the dollars and the 555, and the actual pay is going to be 555 divided by 37, and we get $15 per hour. We are looking at this and we say, okay, if we have an 8 here, that means we're going to round up to 12800 for the first month. 12000, and then here we notice that we're going to look here and round up. So we get 7,500. And we're going to add all three of those together. So 12800 plus 12000 plus 7500. And we get a grand total of 32300. So that's our estimate rounded. If we wanted to find the actual, we just add all three of the numbers. So 12789 plus 11951 plus 7472. And for the actual, we get 32212. So let's start. If we have 23 people, and we're going to subtract 6 for the 14 per hour, and we're left with 17 people. And then from here we've got 12, so we'll subtract our 12, and we're left with 5. So what is the total hourly wage for all 23 people? We can take 6 times the $14. So we're going to get 6 times 14 plus 12 times 15 plus 5 times 18. And we get a grand total of $354, and that's per hour. If each employee works 38 hours in a week, what are the total wages? So if we take 354 and it times it by 38, we get a grand total of $13452. Now, if he has to pay an additional $1,029 to the federal government to cover Social Securities, how much did he have to pay that week? So if we add 1029, that's our grand total. So if it has 4 currents and those are the amperages, what is the total current? So we're going to take 12 amps plus the 29 plus 45 plus 27. And we get a grand total of 113 amps. Okay.